hope I'm audible. Okay, sir. So very warm good afternoon to one and all present here.
Yes, Shanawaz.
I, Shanawaz Sayed, a student of third year Information Technology Department, and all the staff and students of GH Raisoni Institute of Business Management, Jalgaon, an autonomous institution affiliated to KBC and MU Jalgaon, welcomes you all for this wonderful session on the topic Swarm Intelligence, organized by Computer Science and Engineering, Information Technology, Data Science, and Artificial Departments. I wholeheartedly welcome our special guest, Dr. Vanajaroselin ma'am, learned professors, and the distinguished invitees, and thank them from the core of my heart for accepting our invitation. Now, I would like to introduce our today's resource person. Our today's resource person is Dr. Vanajaroselin ma'am. She is currently working as a professor in IAC department at Oxford College of Engineering, Bangalore. She is having 15 plus years of experience in teaching. She has served as a lecturer at Guru Nanak Dev Engineering College, Karnataka, and Brindavan College, Bangalore. Then she has served as an assistant professor as well as associate professor at MBES College of Engineering, and she has also served as an associate professor at AMC Engineering College, Bangalore. She is skilled in C++, Java, SQL, pattern recognition, biometric security, computer networking, and design patterns. Really appreciating, ma'am. Now, I would like to hand over the mic to Dr. Vanajaroselin, ma'am, to start with the session. Before that, a sincere request to all participants to please stay on mute for the smooth conductance of the session. Over to you, ma'am.
Thank you for inviting me. Thank you, Sonal ma'am. It's really a great pleasure for me to be the part of this event. I really feel honored and appreciate all of you to make me to be a part of this. Thank you once again. So today's session, I would like to state about the swarm intelligence. Okay, I would like to share the knowledge regarding whatever we have. So that I would like to share with you regarding the swarm intelligence. Okay, so please let me know, am I audible to all the students?
Yes, ma'am, you are.
Yeah. May I know the audience are only the students or any research students are also there? Final year students. Hello?
Yes, ma'am. From all departments and here, there are students.
Okay, fine. Thank you.
Yeah.
Thank you. Okay. So please let me know that is my screen shareable or not. Okay. So we begin with the topic swarm intelligence. Now, what is a swarm? Okay, and what is an intelligence? We'll focus on this. The intelligence is that it is a part, or a swarm intelligence is a part of an artificial intelligence. Now, what is an artificial intelligence? Artificial intelligence is something which mimics just like a human being. Okay, how the human being do, how the activities they perform, okay, or how they will be taking the decision making. Okay, so we are going to develop such of a systems which is just similar to a human's way of thinking or doing something. Okay, so artificial intelligence is a big and a huge umbrella, we can say. Okay, under that we can take, there are so many things which comes under the artificial intelligence. For example, we can see the machine learning, which is helping us to do the artificial intelligence to work more perfectly. The data science, okay. Then we have the neural network, artificial neural networks are there. So there are so many technologies which is being considered under the umbrella of artificial intelligence. So whatever we are doing today, whatever we are thinking today, whatever we are performing today, it's all about the artificial intelligence. Yeah, I think many of you are more aware and more knowledgeable as compared to me or anybody, that how the technology has taken itself to so much advancement in terms of an artificial intelligence. Now, if you look into the search engine, it is also an artificial intelligence. If you look into your mobile, the whatever the things you want to type, okay, so there also you can find the artificial intelligence. So now we can say artificial intelligence is the next generation or today's generation, and forever in future also we can see only artificial intelligence. So the things the artificial intelligence is making the humans work more easy and understandable, and efficiency is very much increased. Okay, so the next thing is the one more topic, today's topic which I'm going to discuss with you is all about the swarm intelligence. The swarm intelligence is also a part of an artificial intelligence which comes up with the genetic algorithms. Okay, so here the swarm, the word swarm means it is the group. Okay, we call it as a group, or we say collective making decisions, or we say the together. Okay, we make some decisions. So that we call it as a swarm intelligence. The swarm intelligence, why we need to go for the swarm, and why or else we can say group of an ants, you can see that they are moving together to in search of a food. Okay, or we can see the group of birds, the flock of birds, or a school of a fish, you can see. Okay, I'll be sharing you some videos to understand it more so efficiently, so optimized way. What is the process they are taking? So then they concluded that this swarm is helping. It can help us. Okay, we can mimic this particular concept and bring it into the algorithms and take it to the new innovations technologies. Okay, so
Ma'am,
that will help us. Yeah. Hello.
ma'am, sorry to interrupt. Your slides are not changing. So,
Yeah. I didn't change the slides yet.
okay, ma'am.
Okay.
Yeah, got it.
Okay. Yeah. Thank you. The next thing is that we need to relate them. So the thing which I'll be discussing here is what is a swarm intelligence, the examples from the nature we will take. We'll take up some videos to understand, small brief videos are there that will help us to understand more accurately about this. There are two algorithms which I want to focus. There are so many other algorithms are there, but I'll be focusing on these two algorithms. That is ant colony optimization and particle swarm optimization. Then we will be summarizing that why do people uses the swarm intelligence, what are the advantages of the swarm intelligence, and what are the recent developments are there in the swarm intelligence. Okay, so we'll start with the definition. What is a swarm? Okay, I have given you the idea. What is the swarm? I have given you the concept. Okay, why we need to go for a swarm. Now let us define what is a swarm. Okay, the definition says that a loosely, okay, they can recognize, communicate, and or interact with each other. That is nothing but within the collection of these particular interacting agents, the agents are going to do these activities. Okay. The next important point to understand for the definition aspect, the instinctive perception of a swarm is nothing but is a group of agents in a motion. I have given you the example, the group of birds. You notice this in the evening time or in the morning. Okay, the group of birds, they keep flying together in search of a food. Okay, or you can see this ants, they are also in the group, they are also in the search of a food. Now, why I keep on focusing search of a food, search of a food. Now, whenever we say the search of a food, that is nothing but they need to find the shortest path to reach to their food. Okay, we need to find the shortest path to reach to that particular food. So how they are doing and how our algorithms will also do, that comparison we need to make here. So next thing we need to understand is a swarm is better understood if thought of as an agent exhibiting a collective behavior. Okay, they are going to exhibit the collective behavior. So that is the collective behavior. In between, they need to interact, they need to communicate, they need to come to a particular decision. Okay, then only their behavior will be same if they are collaborating with each other. Okay, the next point we'll understand what is a swarm intelligence is. An artificial intelligence technique which is based on, now we are getting into the technology. The previous definition was all about the swarm. What is a swarm? Now we are bringing it towards the swarm intelligence. An artificial intelligence which is going to be, the technique is going to be based on collective behavior in decentralized self-organized system. I didn't mention centralized. Centralized means there is no collective behavior will be found. You might be aware of it. There is a lot of difference between the centralized and decentralized. So decentralized, naturally, it will be considered in terms of a indirect control of it. But the decentralized will be present with respect to this swarm intelligence, as well as self-organized systems will be there. The next important thing is it is generally made up of an agents. We need to consider the agents. And agents has to interact with each other and the environment. Please, can you mute your systems, please? Okay. Then, no centralized control structures will be there. Okay. It is based on group of behavior found in the nature. Okay. The next thing. Now let's take some example of a swarms in the nature. Okay. First thing is the classic example swarm of a bees. Okay. Further we can extend ant of a colony. The agents are going to be the ants. The flock of a birds. The agents are going to be the birds. If you look into the traffic, who are the agents there? Cars will be the agents, or bikes will be the agents, or you can see any of the vehicles will be the agents. Okay, the crowd, in the crowd, if I'm saying, the agents will be the human. And if you get into the immune system, then agents are nothing but they are the cells and the molecules in our body. Okay, now if I'll be telling you regarding the swarm robot, there is an invention called as a kilobot. I'm going to show you how the kilobots are helping you, okay, to form the how our cells, okay, antigens in our body kills the bacteria. We can create or mimic the same with respect to the kilobots. Okay, then together they'll come and they will be showing the demonstration of how our cells will be functioning. Okay, we can create that and we can demonstrate that. Okay, so likewise the swarm in the nature we can take up the examples. Okay, let's focus a little bit about the history of a swarm intelligence. The first introduced by the Benny and Wang in the year 1989 with a study of a cellular robotic system. This concept was expanded by the Bonobu, Dorigo, and Theroux in the 1999, and it is widely recognized by the colleges. Okay, the next thing. Now I'll be showing you one video to understand the swarm intelligence, and then we'll further discuss about it. Okay, let's understand. Hello. So in this particular video, we could come to know that what is an idea of a swarm. Am I audible to all the audience, please?
Yes, ma'am.
Okay. So in this technology, in this video, the technology is stating that how we can make the decisions with respect to the swarm. Now, in this analogy, we could see that the group of people were ordering for a food, and they wanted, some people wanted to eat this, or we'll understand that is going to help us not on the basis of a majority, instead on the basis of an optimized way. Okay, so the algorithms were helping us to take decisions or to make any search of a path or to go into the search space. It will be getting into the optimized way. Okay, so the next we'll take one example of a swarm robot. It is also a part of a swarm intelligence that can communicate locally and operate in a biological inspired manner. Okay, so this is a kind of a development of a research. This is a current developing area of a research, we can say. Okay, now let's take in, there are so many robotics are there with respect to the swarm. Out of that, I have taken for today's discussion is a kilobot. Okay, the development of a kilobot. Now the kilobot, the word itself says it's of a very small size. Okay, the size or the size, if you are considering, it is 3.3 centimeter in tall, low cost swarm robot. Okay, developed by Radhika Nagpal and Michael Rubinstein at Howard University. Okay, they can act in group up to thousands to execute the command programs by the users that could not be executed by individual robot. I think this technology has come up with many movies of fiction movies. We can see the robots are there. That is a small kilobot robots are there. Okay. Now let us focus the technology part of the kilobot. In the kilobot, there are so many robots will be constructing in a small fashion. Now what we write a program and the same program is given to all the robots. Okay. Now they start collectively, they start to perform, and whatever the instruction in the form of a program has been done, they start to perform in the same manner. That is nothing but the kilobot. Okay, we'll understand with one more video. Is the video audible and visibility is clear with respect to the video? Hello?
Ma'am,
Is the audio hearable? Hello?
no, ma'am.
No. Okay, I'll just explain this. Now, if you look into this swarm kilobot, okay, now it is taking the example of the group of the flock of birds. Okay, all this technology. This is the molecules of a cell. Okay, this is the group of an ants which is searching in search of a food. Okay, now keeping them. This is the school of a fish we can see. Then these are the kilobots. Okay, now this technology, how it works. So if you look into this, they are very tiny in the size. They are the swarm kilobot, we can say. They are very tiny of 3.3, which is developed in Howard University. Okay, to this, they all are working together. So they are organizing whatever you are programming here. Now the program has been given or an instructions has been given to this particular thing. And then, okay, these are the set of instructions which we are giving. And now they are all performing together. Now they are going in search of a food. Now what they are doing is, this is being little inefficient in terms of getting in search of the food. So the researcher has started to improvise the algorithm. The algorithm has been improvised in such a manner that they need to be functioning just like a bacteria's finding of the food. Okay, then now, if you look into this example, now this is that is WBC and RBC of our blood cells. They are going to kill the bacteria of our body, and they are performing. So now we can use the kiloboard to demonstrate such kind of an activity which is going to perform. Okay, so this is a kind of a kiloboard which is helping. Okay, so this is how we can see the swarm robotics are helping us to do just like a biological inspiration, we can say, or whatever the concept or whatever the thing you want to show, the demonstration can be done by writing the set of code or instructions with respect to the kiloboards. Okay, so there are n number of examples we can go for it. Now we'll focus on how the swarm will be working and what is inspiring and how the developments will be. Okay, with this rise of computer simulation model, the scientists began by modeling the simple behavior of an ant, leading to the study of the main basic concept comes with respect to an ant, leading to the study of how these models could be combined and then produce the better results than the model of the individual. So this we can say it is an insight into the nature of a human, the society and the world. So we can understand it more deeper, we can get into. So then the further leading to adaptive observations in the nature that will be done to the computer algorithms. Now here, the basis of a swarm is about the insects. Why insects? We need to understand that. The insects have a few hundred brain cells. Okay. However, they are organized insects have been known for first thing architectural marvels, complex communication system, and then resistance to the hazards in the nature. They are very good resistance towards that. So in the year 1950, E.O. Wilson observed that a single ant acts almost randomly, often leading to its own demise. Okay. Then that is, you might have also, they have concluded that a colony of an ants provide the food and the protection for their entire population. Then, with respect to this, the algorithms has been introduced. Okay, so the name of the algorithms was given as an ant colony optimization algorithm and particle algorithm. Boys, they started to think that how better way we can adopt to get the water to our village. So they found that there are two paths are there. Okay, this is one path and this is another path. There are two paths are there to bring the water to this particular place. What has happened is both decided that let me go into this path and you go with this path. Whoever reaches there and comes back, okay, reaching there, get the water, bring it back to this particular point. Okay, So likewise, we'll be doing it for 3-4 times, and whichever will be the best path, that we will fix it for the this getting the water from this particular pond. So this boy has started. Okay, he reached. Okay, he reached till this, but this boy has already reached to the destination. Okay, so half of a way he has covered, but he has reached to the destination. After that, he filled the pot and brought back. And when he was bringing it, he spilled the water. That was their condition. They are supposed to spill the water while coming. Okay, and then they will go back, then they need to spill the water. So this was the condition at the initial stage. Now this boy went reached early as compared to this. Okay, filled that, and he started to pour the water as he was moving ahead. Okay, and similarly when he was about to reach here, this boy reached, and he also took the water and started to move, and he was that this path is not optimal path. Okay, this path is more optimal as compared to this path. So therefore this path becomes the optimal path for getting the water from the pond to the village. Okay, so this is one analogy to understand how it will be done. Okay, now let's look into the same concept will be adopted by this algorithm, that is ant colony optimization algorithm. Okay, what this algorithm is: the study of an artificial system modeled after the behavior of a real ant colony and are useful in solving the discrete optimization problems, which is introduced in the year 1992 by Marco Dorigo. Okay, originally called it as the ant system, and has been applied to the real-time problems such as the traveling salesman problem and other shortest path problems, and the several NP-hard problems. Okay, so this algorithm has been applied and they got the success with respect to it. The next one is that it is the population-based meta-heuristic. Now this is a concept of an AI where we can say accumulated heuristic knowledge will be considered. That we call it as a meta-heuristic. If you take only heuristic, it is just one particular decision making. Now meta-heuristic is that the many together come to, the many points are considered to make a particular decision making. Okay, which is used to find the appropriate solution to difficult optimization problem. The next thing, what is a meta-heuristic? It is referred to a master strategy that guides and modifies other heuristics to produce the solutions beyond those that are normally generated in the guessed for a local optimality. Okay, so this is given by Fred Grover and Manuel Lagone, with the definition was being suggested. Or instead of getting into so much of this, we can simply state that it is a set of algorithms used to define heuristic method that can be used for a large set of problems. That is the definition of a meta-heuristic. And one more point to be noted, in any of these algorithms, either an ant colony optimization algorithm or a particle swarm optimization algorithm, both will use the meta-heuristic concept. Okay, so we can say this optimization algorithms are totally based on meta-heuristic. Now let's create an artificial ants. Okay, the artificial ants are nothing but the set of software agents which are working totally on a stochastics, and they are based on the pheromone model. Okay, what is a pheromone? It is nothing but whenever the ants get towards the food, they want to show the direction to the other ants to reach towards that particular food. They leave the pheromone while they will be coming back. So they mark the path with respect to the pheromone. Okay, so here The artificial ants, it is also the base of an artificial ants is also based on a pheromone model. Now, pheromones are used by the real ants to mark the paths. Ants follow these paths, that is nothing but trail following behavior. Okay, so incrementally build the solutions by moving on a graph. Constraint of the problem are built into the heuristic of the ants. Okay, now let's take this example for aging behavior of an ants. Okay, so this is the nest of an ants and this is the food they want to reach. The two ants start with an equal probability of going on either path. Okay, they reach, but once it reaches, it is still reaching. The ant on a shorter path has a shorter to and fro time from its nest to the food. Then the question comes, like, why this ant path only we can decide, why not this? Do this ant only know that it has reached early, or this ant says that no, I have reached a little late? No. What happens is, once they will be going back, both will leave the pheromone. Okay, they will be leaving the pheromone and reaching to the nest back. heating oil distribution, and data mining. Okay, so these are the applications where we can apply. One more algorithm is there, which is a particle swarm optimization. Now let me give you the brief introduction towards this algorithm. Here we'll be considering the flock of birds. Okay, the birds are trying to reach to that particular food. They have targeted it. Okay, so in place of a bird, we take the particles. The particles are supposed to be in a motion. Now, if I am taking the motion here, I want to state that I need a velocity. Okay, I need to have the velocity. I need to check how the positions to be updated. Okay, so there are two things to be observed here: the position and the velocity. Okay, so based on these things, we can now decide like how the swarm will take a movement from one place to another place. Okay, let's look into the particle swarm optimization, a pollution-based stochastic optimization technique, which searches for an optimal solution in a computable search space, which is developed in 1995 by Dr. Eberhardt and Dr. Kennedy. The inspiration for this particular algorithm is the swarm of bees, flock of birds, and school of fishes. Okay. The next thing, this particular particle swarm optimization algorithm, individuals strive to improve themselves and often achieve this by observing and imitating their neighbors. And one more point to be underlined here, the neighbors doesn't know where is their destination, but they just mimic, okay, or they just imitate what other neighbors are doing. Okay, that is the birds, the flock of birds. If we look into, there will be one leader of a bird which will be taking all the flock of birds. The others are simply following it. Okay, or a school of a fish you take,